Bayes' strain theory. This is a very important theory when we study alicyclic compounds, aliphatic and cyclic organic compounds. See, when the carbon is sp3 hybridized, and these sp3 hybridized carbons form a ring, and the ring is a planar system, then what will happen? Certainly the bond angle will not be 109 degree 30 minutes. The bond angle between sp3 hybridized bonds in the case of a carbon is 109.5 degree. But when the compound is having these things, number one, it is a cyclic. Number two, it has carbon atoms with sp3 hybridization. And number four, the ring is planar. When these conditions are there, certainly the bond angle will not be 109 degree 30 minutes. And this bond angle deviation from the 109 degree 30 minutes will vary with the size of the ring. So this is the first postulate of Bayes' strain theory. So what is the first postulate? The sp3 carbon and the cyclic compound is planar, as the carbons are sp3 hybridized and it is in a plane, and these carbons are forming a ring, and because of the ring structure and because of the planar nature, the bond angle will not be 109 degree 30 minutes, and because of this there is a deviation, and this deviation varies with the size of the ring. This is the first postulate. And the second postulate, the deviation in the bond angle, it causes a strain, and this strain, it causes instability of the molecule. So the molecule becomes unstable because of the strain caused by the deviation in the angle. And the third postulate is, greater the deviation, greater will be the strain and greater will be the distortion. This is the third postulate. And the fourth postulate, the more stable a ring system, the more easily it is formed. This is the fourth postulate. Now I would like to explain this with an illustration. You can take this cyclobutane or cyclopropane. I think you are able to see the board now. If you take the cyclopropane is supposed to be like this. If you measure the bond angle, this bond angle is supposed to be 60 degree because it is triangular planar. Because we are assuming that all the carbon atoms are sp3 hybridized, and also the ring is in a plane, and because of the planar structure, the angle is 60 degree. But originally the angle supposed to be, look here, if it is sp3 hybridized, the angle supposed to be 109 degree. This angle should be 109.5 degree. Therefore, the deviation here, it is 24.75, and here it is 24.75 degree. So this is the deviation. What is the bond angle deviation? It is 24.75 degree. But in the case of cyclobutane also you can calculate. Cyclobutane, the bond angle is 90 degree, but which is supposed to be which is supposed to be 109 degree 30 minutes, 109.5 degree. So the deviation in this case on either sides it is 9.75 degree, and here also 9.75 degree. So this is how the bond angle variation is observed. So internal bond angle can be calculated. Internal bond angle can be calculated using the formula 180 n minus 2 divided by 2, where n is the number of carbon atoms. I think you are not able to see the formula. It is 180 into n minus 2 divided by 2, where n is the number of carbon atoms. So when you substitute the n as a 3, 4, 5, 6, 7, and 8, you can see, I will give you the various data. When n is 3, it is 24.75 degree. When it is 4, it is 9.75 degree. When it is 5, it is 0.75 degree. And when it is 6, it is minus 5.25 degree. When it is 7, it is minus 9.54 degree. When it is 8, it is minus 12.75 degree. So the 5-membered and the 6-membered, you look here, the 5-membered and the 6-membered alicyclic rings, they show relatively minimum deviation, relatively. That is why the cyclobutane and the cyclohexane are found to be relatively more stable when you compare the cyclic compounds of aliphatic compounds. And also, there are additional evidences for the Bayes-Strian theory. Suppose if you take a compound with a double bond, the double bond can be considered as two-membered ring. This can be considered as a two-membered ring. So in this case, the deviation is 109.5, right? And minus, it is n minus 2, so 0 minus 0 divided by 2. So this will be equal to 54.75 degree. So the deviation in the case of an alkene is 54.75 degree. And the alkenes are highly reactive and highly unstable. So this is an evidence for the Bayes-Strian theory. And one more thing, when you calculate the heat of combustion per CH2 group, just a minute, I'd like to. The heat of combustion per CH2 group for various cyclic compounds, I'm going to compare. You can see here. See, for cyclopropane, it is 697 kilojoule per mole. And for cyclobutane, it is 686 kilojoule per mole. For cyclopentane, it is 664 kilojoule per mole. For cyclohexane, it is 654.4 kilojoule per mole. When we compare these things, these two things are greater than these two ring structures. And you can see, and these two values are close to the CH2 combustion value in the case of open chain compounds. If you take an open chain compound, in the case of open chain compound, the heat of combustion for one CH2 group is 658.44 kilojoule. So heat of combustion, what is heat of combustion? You take CH2 and you are converting this into carbon dioxide and water. So if it is mere combustion of CH2, whatever may be the place where the CH2 is present, this value supposed not to change. Whether it is an open chain compound, whether it is a closed compound, it is not going to change because it involves simply the oxidation of a carbon and a hydrogen. Carbon becomes carbon dioxide and hydrogen becomes water. But because of the presence of the CH2 group in the cyclic structures and because of the internal strain it is experiencing, there will be variation in the heat of combustion of a CH2 group, and it is for cyclopropane it is 697 kilojoule per mole, and for cyclobutane it is 686, and for cyclopentane 664, and cyclohexane it is 654. And you can see here it is higher and here it is lower, and it is almost equal to the heat of combustion of CH2 group in the case of open chain compound. So this is another evidence. So this shows that smaller the heat of combustion per CH2, greater will be the stability of the compound. So if the CH2 combustion is smaller, and if it is close to that which is observed in the case of an open chain compound, then the stability is higher. So this is the understanding that we are getting from the Bayer's strain theory. And another thing, there are two limitations of Bayer's strain theory. What are these limitations? One thing we have said as an evidence, the same thing can be discussed as the limitation also. See, what we discussed in the case of alkenes, the alkenes can be treated as a two-membered ring structure. When the two-membered ring structure, if you take the bond angle to be 180 degree and the n to be 2, then the deviation is found to be 54.75 degree. And because of so much deviation from the sp3 hybridization, it is expected that the alkenes supposed to be more reactive and highly unstable, and that is true in certain cases. But alkenes do exist. They show some stability, which was not able to be explained by Bayes' strain theory. So that is one limitation. And the second limitation, CH2, the heat of combustion, you can see for 7-membered ring, it is very high. It is expected to be high, but practically it is less. It is 662 kilojoule per mole, which is very close to that of the 5-membered and 6-membered or even open chain compounds. So when the carbon count is between 7 and 17, the value of the heat of combustion of a CH2 group varies between 658 kilojoule per mole and 664 kilojoule per mole, which is almost equal to that of the open chain compounds. So all cyclic compounds more than 4 carbon atoms will have similar stability as that of open chain compound. This is in contrast with the Bayes' strain theory, because according to Bayes' strain theory, the larger rings are supposed to have appreciably less stability, but 17-membered rings have also been synthesized and they also show stable existence. So this was not explained by the Bayes' strain theory. So when you study the Bayes' strain theory, you have to study these three important aspects. Number one, what are the postulates of a Bayes' strain theory? What are the postulates? Number one, sp3 carbons, when they are present in the ring and when the ring is a planar, there is an angle difference, and the bond angle assumed by this compound is not 109 degree 5 minutes. So this deviation varies for various sizes of the rings. This is the first postulate. And the second postulate, the deviation in the angle causes strain or instability. Number three, greater the deviation or distortion, greater is the strain and the greater is instability. And the fourth one, the more stable a ring system, more easily it is formed. And we have seen what are all the deviating points. And also the additional evidence for the Bayes strain theory, the first one is the two-membered ring existence, and the second one is the heat of combustion per CH2 group in the molecules. And the limitations, there are 2 points. The first one, the existence of a two-membered ring, the alkenes, and the second one, the heat of combustion of the ring systems with carbon number 7 and more up to 70. So these are all the important things. Any doubt you have?